All right. Good morning, everyone. And kind of difficult to follow the lead. I think there were pretty exciting cases that Krishna presented in the previous session. And I will, try to bring a slightly different angle to how we are applying generative AI in the energy and automation domain. So yes, yeah. For those of you who are not familiar, Schneider Electric is right at the intersection of energy and AI. I think Bruce mentioned at the beginning that we all have some level of association with the data centers. So data centers is one of our big part of businesses of 40 billion euros revenue that we did in 2025. We provide everything that is required from the. Can you hear me? Okay. Thought I lost it for a bit. Everything from getting it from the medium voltage substations, getting it into power centers that essentially downscale it, and then we provide them to data centers, racks that house all the equipment, all the GPUs that we use for AI. And not to forget, the cooling that is required to keep all these things running, because thermal management is one of the most important aspects of any data center. By the way, they also spend a lot of energy in cooling it. So we are, in 100 plus countries, and we have, buildings, data centers, industry, and infrastructure. Been around for a very long time, 190 years. The other interesting fact I saw in the agenda that there is a discussion about the lighthouse factories from World Economic Forum. So we happen to have about 9 of them, around the world, and a few of them in, US, not in Massachusetts, but outside Mass. Okay, so let me move to the, topic of AI. So we have been investing in AI capabilities inside Schneider before the ChatGPT movement. I think that's the one that everyone kind of recognized that, hey, we all have to deal with AI. But even before that, we knew this is going to be a transformative technology for us, and set up the organization, processes, tools, everything that is required with the idea of going to AI at scale. Because we've seen places where everything can happen. It's a technology is being democratized. You can build anything that you want. But then the question is, can you do it responsibly, and can you do it at scale? And the same thing applies to generative AI, because generative AI suddenly made it even more easy. It's kind of funny that a few years ago, we were hiring all the data scientists, dealing with sensor data, dealing with all of them was a pretty complex problem. If I go to a software engineer, then they say that, hey, can you upskill? Say, this is a really different domain. Now, with the generative AI, it is almost becoming an extension of software engineering. There are so many software engineers that are easily upskilling because all you have is an API endpoint. You call an LLM, you get something back. You can have a conversation back and forth. You can use agents and whatnot. So, but the principles of applying this still remain the same, which is number one, domain expertise. I think this is something that is going to be irreplaceable, even if models tend to become bigger and bigger, more capable. I think we still need the domain expertise, because this is what people have, and it is continuously evolving. Especially in the industrial domain, such as electrical knowledge, where there is a lot of safety at risk. You cannot just delegate it to some instructions that come from an unknown model. The second thing is the responsible AI, because we are a large company, we also provide solutions to critical infrastructure. This is not something that you can take lightly. So the idea of having a responsible AI practice was from the get-go for us, that we wanted to have a centralized mechanism, reviewing models. Not to mention that since we also have a strong European presence, the EU AI Act also guides a lot with respect to responsible AI. And the last one, which kind of leads into the main topic of today's discussion, is the value driven. So there is all sorts of things that can be done, but then which one do you do? and the one that you do is what drives value, for the company. And we look at it in two ways. You have the value that is in the near term, that is going to solve a very specific problem that you have to do, and then something that is also may not be as apparent today, that has to be solved in I don't know 3 years, 4 years, etc. That we can start to invest on and builds our own internal capabilities. However, it is very clear for us that we are not in the business of building AI models, broadly speaking. They are there to help us internally and also help our customers in the domains, in the products that we serve. If I can make a model that predicts the remaining useful life of a battery in a UPS, or number of cycles remaining in a switchgear, etc., that's useful to us and useful to our customers. That's the one that we focus on, not building So for today's discussion, I thought we have a continuum of use cases that we can see. So to put the frame, the first thing is to looking at as knowledge management. So this is a topic that is common everywhere. I think this is the first use case. If you remember, a couple of years ago, there is, RAG was everywhere, retrieval augmented generation. So we have multiple such knowledge management applications inside the company. And I'm going to talk about something very specific to the industry, which is in the grid, how we use generative AI there. The second one is moving up the chain to become a bit from an assistant in expert tasks, things that used to require experts, how we can empower them, how we can scale them using generative AI. And then we start to look at generative AI is not just as a way to deal with the text only, or deal with knowledge tasks, but also helping us manage things, do things. So this is from answers to actions. How we are going to apply this in the large context, like buildings, etc., with our new solutions. So let's jump in. So I don't know how many of you are familiar with, what is, sorry. Okay. I don't know how many of you are familiar with how grids are managed. So the grids have these giant control panels. I'm talking about the electrical utility grids. I mean, there are about, give or take, I think 3,000 of them. But, there is a class A that are really complex in US. They all have like big control rooms. They've got, the diagrams of the entire, grid. And there are operators that are monitoring it. They are the ones who are looking at when things go wrong, when there are power outages, how we are going to get them back, etc. So this is a really complex operation. Think of it like air traffic control, right? Excepting that here we are controlling electrons and, making sure that nothing, ever goes down and nothing ever catches fire. Now, the other important aspect of this particular application is this is air-gapped environment. Everything that runs here is not connected to cloud. They want to make sure that it is, there is no risk of, anything going down, cyber attacks, etc. It's air-gapped. So our challenge here was to build an AI assistant that is using generative AI in an on-premise air-gapped environment. So if you think of most of generative AI, you have an endpoint somewhere in the cloud, and then you get an answer. But the challenge we have taken is working with our technology partners, how to build something that runs locally using some of the open source models and using our technical documentation, that is ingested to answer questions to operators, right at that time, and then also taking them to the right parts of the application. This is key. If they, through function calling, saying that, okay, there is a specific alarm, specific trip that is happening, and, where to look for, etc. It takes a long time to train our, these operators in the grid, because, again, it's risky environment. You don't want to give it to them. What we are able to do is to dramatically reduce, the onboarding time for many of these people. And we have done, of course, this was not done without an assessment on the quality of answers, with the experts validated, with our customers, and also the response time. The response time is key. You press something, you don't want to wait for 10 seconds to get an answer. So we start to see, number one, a high accuracy answers. And then we also see, the answers remain grounded. This is another thing. Anyone who has built generative AI solutions in the industry knows that the biggest problem is to put in the guardrails, that you don't want it to be answering random questions. And then, we have dramatically reduced the onboarding time. And this helps the operators be more confident of finding answers and reacting to situations in this highly critical environment. Now, if you move up the chain, I said this is the assistant that is helping the people work, get some help that they could have easily found, maybe through search, going through multiple iterations. The expert tasks, that are required in the industry. I don't know how many of you know PLCs, programmable logic controls. By the way, Massachusetts happens to be the place where it was first invented, in Bedford. In 1960s, Modicon control, which incidentally is a brand of Schneider Electric. So these are the critical elements of a factory. You have instructions that are running, there are millions of lines of code running, bazillions everywhere. The problem is, no one outside this industry knows much about this. You cannot find this easily in, Claude or, in Codex, the amount of libraries, because these are all inside companies. Granted, you can generate some, decent enough PLC code by having a clever prompt, etc., but doing it reliably, consistently, and more importantly, having access to the company's libraries, because they have built, various ways of doing that. So what we have built is a copilot that uses, of course, the LLMs, but with a lot of grounding, a lot of retrieved augmented generation, a lot of guardrails, and more importantly, access to the local environment. Looking at the customers, and even coding standards. People have things that they would like to follow. If you have a large factory that has got multiple controllers, you don't want everything to be in any form or fashion that you would like. So the idea here is that this, number one, is starting with simple code explanation. You have an existing code base, someone wants to come understand it, you can have code explanation, and then it simplifies the work that they have to do. And the other important aspect is test generation. And I think those who have been using coding assistants know that there has the test coverage has skyrocketed since we have the automated ones, because it used to be a painful task what people wanted to do, but we tried to avoid, and now we can generate them easily. So this the impact that it has is in terms of managing the existing code base much better, writing new programs very easily, and more importantly, a big part of the upgrades and modernizations companies have to do is also to rewrite code. And many times this is the blocking point. I can get a whole bunch of new generation PLCs because I've been there for 30 years and I need to upgrade them, but I also need to write code, because not all of them is just compatible. So this is another example of how we can use generative AI for impactful use in industry. The next one in the continuum is, Foresight is our new platform that is to manage buildings. Buildings are an essential part of our modern life, and they are also the ones that consume about 30% of energy globally and 50% of electricity. So they have a large footprint, both residential and commercial. So what we, you see here is that this is an integrated solution for power and building management, which used to be two distinct domains. You'd have like a meter, that manages power flow, etc. And then you have a BMS that is managing all the points in that. We combine all of them because they are an integrated system essentially. And having an assistant that is not just talking to, that you talk to or get suggestions, but the one that's actually providing you assistance in a proactive way. For example, if there is an issue with a chiller, for this building, how it can alert you of things that are going to happen and propose a solution. There is still a human in the loop because these are complex environment, and especially data centers are also buildings, and this is also targeted data centers. We want to have human in the loop and make sure that there is accountability for that. But now we are moving into an area of providing intelligence, combining both the domain expertise and the knowledge that is embedded in the LLMs. And by the way, all of this also has to run in a controlled environment, because not everything in the buildings is going to be running in the cloud. So hope this gives you a good sense of the applications that we have on the generative AI in the industry and energy domain. What I wanted to do is also just throw a light. We apply generative AI for many usages inside the company. We've got lots of knowledge assistants, for customer care, customer support, and something like RFP, RFQ consolidation, and all kinds of things. But coding is one of the really important tasks that can be augmented by generative AI tremendously. I mean, the benefit that we see is enormous. So we started on the journey, with we use GitHub, but we also use other models, outside OpenAI. We started initially for code completion, and then doing lots of generative, the unit tests, explain code, fix bugs, the agentic software development. Then we start to get into more interesting things this year. MCP integrations. We've got a large code base. I mean, we have hundreds of software applications entered the company. And some of them are quite old, and we need to modernize them. We need to upgrade them. We see a significant impact of this having, on our, software development cycles, because there is, a lot of code, a lot of applications. I mean, if you are dealing with, let's say, IoT devices, right? I mean, there is a lot of similarities, whether I'm getting data from a transformer or a switchgear or a UPS, there is a lot that we can reuse. We see that there is faster development cycles, higher developer productivity, and more consistency and quality. The other big problem that people may not realize in large companies is the tech debt. There is always something that was written 5 years ago. Some person developed it, and then they moved on. I mean, they were not even left the company, but they're somewhere else in the company, and then someone has to go deal with that. I think dealing with the tech debt is a key point. And then, finally getting into a much more streamlined. So we have I mean, the user adoption has been fantastic. I think it speaks volumes to the progressive look on how we use these tools, not simply using this as a cost reduction initiative, but actually something that accelerates our software development. So I'm looking at the clock. I think I'm on the yellow zone. So the closing thoughts from my side. I think GenAI has evolved, and there is a lot of room for it to grow. This, we are just getting started. If you talk to anyone from the big AI companies. However, the adoption, the application in the domain such as industry and energy, it has really unique challenges, starting with primarily on-prem mode. I mean, you have to think how all these things will work in a highly constrained environments. Not everything is going to be on the cloud. And secondly, purpose-built models. I think there is a case to be made. For example, new kinds of generative models, for time series data. That was not a big topic. People talked about only language. Now we can see, can time series data, benefit from this? And lastly, I think the impact and returns from this is going to be enormous. I think this is an area where generative AI, I mean, AI in general, and particularly generative AI, is going to make huge impact. Given the scale of industrial deployments, how critical they are. They're invisible, but they're essential. And of course, we are hopefully entering a new era of manufacturing renaissance. And I think the students here would be excited about being part of this renaissance. With that, I am almost on time. So I don't know if I will have time to take any questions. Okay, maybe one question if there is time. Okay. Okay.
So as you shift to more agentic AI usage, how are you changing the amount of effort that you put into evaluations, given that you're in a regular environment high reliability is an expectation.
Yeah. So first of all, in terms of the validation part is significant, right? I mean, we have to get people in. So the paradigm has shifted from simply code development to how do I validate it first, bringing in SMEs, bringing in, people who are responsible, for the ultimate deployment at customers, et cetera. So that's number one. Second thing is we have been building the AI governance practice, and we are kind of strengthening with having all kinds of guardrails, and there is a big compliance that we also take into account. So the investments are certainly increasing on the other side. So when we reduce on coding, because coding can be done easily, the other side, the validation and governance is increasing. Right? Thank you very much.
Thank you so much for sharing your insights today.
Right.